Sorry, the video cut off in the middle of that as I was writing that example off. So another example here. Let's take the square root of 24 and let's add to that the square root of that's a good one, 54. Yeah, let's do 24 and 54. And so here it doesn't appear that I can combine those because they're different roots. However, if I simplify them first, square root of 24 is the same as, well, 4 times 6. And then if I take the square root of the 4 and the square root of the 6 separately, I get 2 root 6. The root of 54 is really 9 times 6. And if I take the root of the 9 and the root of the 6 separately, I get 3 root 6. And I'm bringing down my plus. So now I'm adding these together, and 2 root 6 plus 3 root 6, that should give me 5 times the square root of 6. And that's my simplified form. So it actually did simplify, and I could combine them after simplifying each term individually. Okay, and often that will be the way to get the best simplified form, or to get the common radical so that I can add them together. Okay. All right. We can also look at some examples where we can use like the distributive property, so multiplying some larger groups of terms together. Something like the square root of 2x times 5 plus the square root of 6x. Okay, and so on this one I distribute this entire root, distributes in, and I get, well, 5 is on the outside of a root, it's not in a root, so I got to keep those separate. 5 root 2x plus, now this other root is going to, I can combine those. 2 times 6 is 12, x times x is x squared. And then on the second one I can simplify because the 12 now has a factor of 4. I have a perfect square factor now. So this becomes 4 times 3 times x squared, which is really, well, root 4, root 3, and root x squared. So that's a 2, a root 3, and half of the 2 is just 1, so that's an x. And so if I bring everything down for my final answer, I have 5 root of 2x plus 2x times the square root of 3. That would be my final simplified version. Okay. Alright, you can also do some like FOIL method distributing, where we have some larger things like root 2 plus root 3 times 3 minus root 6, or something like this. And so here I can use the FOIL method, or the distributive property. Root 2 times 3 is 3 root 2. Root 2 times negative root 6 is negative root 12. Root 3 times 3 is 3 root 3. And root 3 times negative root 6 is negative root 18. So if they're under a root, I can combine them. If they're not, if one is not and one is, then I cannot combine them. Then we take and simplify the root 12 and the root 18, because those can be simplified. I'm going to skip a few steps here. I know that root 12, we've already seen that, is 2 root 3. So that's minus 2 root 3 without showing all the work there. The root of 18, well, I know that 18 is 9 times 2. When I take the root of the 9, I will get a 3, and the root of the 2 stays. So that's a 3 root 2. So this one has lots of 2's and 3's in it. Oh, and notice, this is kind of interesting. We have a 3 root 2 and a minus 3 root 2. Those two things actually drop out. They add up to 0. And so the final answer on this one, bring it over to the side here, oh, I almost missed my negative, is negative 2 root 3 plus 3 root 3. And oh my goodness, I almost missed that these two are like terms. How did I do that? These are like terms, and so negative 2 plus 3 is just simply a root 3. That's an awesome problem right there. As long as I did all those steps right, I don't see any mistakes. Just double checking to make sure that everything worked out. That one is 2 root 3, that one is 3 root 2. Those dropped out, those added up to 1. There it is. So that was a pretty cool problem.